In 2021, two scientists built a simulation of Earth's entire future. Then they ran it 400,000 times. They were hoping, at least once, it would come back different. It never did. They weren't looking for a disaster. They were trying to solve something completely different, a question about alien life. If a telescope 100 light years away pointed itself at a random planet, how would it know anyone was home? The answer is oxygen. It's the loudest biological signal in the universe, a gas so reactive that it shouldn't exist in large amounts unless something is actively making it. So, Kazumi Ozaki and Christopher Reinhard modeled a planet that already has that signal. Ours, sun, rocks, oceans, climate, all of it projected forward in time to see how long that signal would last. And somewhere in that model, something started going wrong. Not with the sun exploding, not with an asteroid, something much quieter. The oxygen started disappearing. At first, this looked like a bug, so they reran it. Different starting conditions, different variables, 400,000 attempts to make it stop. Every single run ended the exact same way. But that wasn't the part that should unsettle you. This part is the process causing it isn't rare and it isn't Nyadan. It's already running. Right now, underneath everything, the sun has been getting brighter since the day it was born and it has no plan to stop. That heat is quietly rewriting the sky. Faster heat means faster rock chemistry, and faster rock chemistry means one thing. The carbon dioxide plants breathe is being pulled out of the air permanently, 1 degree at a time. No off switch, no negotiation. Somewhere down this line, the fuel plants depend on simply runs out. That should be the scary part. It isn't. Because here's what the researchers didn't expect walking in. When the collapse actually starts, it doesn't creep, it falls off a cliff. Their models show oxygen crashing by a factor of 1,000,000, a geological blink of an eye. For comparison, the last time Earth's atmosphere changed this dramatically was 2.4 billion years ago, when oxygen first flooded in and rewrote the rules of life completely. This is that event, running backward, and it happens faster than the original ever did. So, when does this actually happen? Their answer? Roughly 1 billion years from now. Say that number slowly. 1 billion years. Long enough that it shouldn't matter to anyone alive today. Except the mechanism causing it isn't waiting for that date. It's running right now, 1 degree at a time, with or without an audience. And it gets stranger. Oxygen doesn't just vanish and leave silence behind. Something rushes in to take its place. Methane. Eventually reaching roughly 10,000 times today's levels. Picture it. The sky over every ocean, every mountain, every empty street on Earth, thickening into a solid, hazy orange. The exact color scientists see today staring back at them from Saturn's moon Titan. Not a metaphor, a real place, already sitting out there showing us our own future in advance. And without oxygen, there's no ozone layer left standing, no shield. Whatever is still on the surface faces raw starlight, on a planet with nothing left to block it. Here's the detail that makes this genuinely eerie. Nobody is around to see it happen. By the time the sky actually turns orange, nothing complex enough to notice is still alive to notice. So what's actually left? Underground, in ocean vents, in the same oxygen-starved cracks where life first began, billions of years earlier, anaerobic microbes are still there, still dividing, completely unbothered. They never needed the blue sky. They were never built for that world to begin with. Which raises a question this video has been circling the whole time. Was the Earth you're standing on right now the normal state of this planet? Or the exception? Here's the number that answers it. Earth is about 4.5 billion years old. For its first 2 billion years, there was no oxygen in the sky at all. Then came roughly 2.5 billion oxygen-rich years. The era that built coral reefs, dinosaurs, rainforests, and you. That era ends, based on this research, about 1 billion years from now. The only version of this planet that could ever produce something like you. Makes up roughly 30% of Earth's entire lifespan as a habitable world. And even that number is generous. Oxygen has filled the sky for 2.4 billion years. But animals, anything that moves, breathes, hunts, or thinks, didn't show up until about 540 million years ago. Which means creatures like us only exist in the final sliver of an already narrow window. A short, recent flicker, near the very end of the one chapter of Earth's story that could ever produce us. For most of Earth's history, nothing here could take the breath you just took. For most of Earth's future, nothing here will be able to take it either. You exist in the narrow, brightly lit middle, the one stretch of time this planet ever agreed to make air that's something like you could breathe. Somewhere, a billion years from now, the sky over this exact spot turns a thick, silent orange, with nothing left to inhale it the way you just did. And somewhere out there, right now, another telescope, pointed at another planet, around another star, might be looking for exactly the same signal we once had. Oxygen, a little too abundant to be an accident. If it's watching Earth a billion years from now, it won't find that signal anymore. It'll just find methane and orange skies and silence. The strangest part isn't that it's going to happen. It's that it was already decided, quietly, chemically, by a sun that started brightening long before you were born and has never once stopped for anyone waiting to see how the story ends.